Hi, today we're going to look at problem solving with Venn diagrams. So Venn diagrams are used to illustrate or show and solve real world problems. And when we look at Venn diagrams, we focus on the number of elements in each region instead of focusing on where a specific element is placed and what the specific element is. So when creating your Venn diagrams from a word problem, you want to make sure you work from the inside first because this is going to keep you from counting things twice. So let's look at an example. A math club has 29 members. 21 have a tablet, 16 have a TI-84 calculator, and 13 have both a tablet and a TI-84 calculator. So we're going to place this information on the Venn diagram. So we have a tablet and a TI-84. All right, so working our way from the inside, it says 13 have both a tablet and a TI-84 calculator. So 13 goes in the center. Now, if we work backwards, it says 16 of them have a TI-84 calculator. So the 13 people in the middle that have both a tablet and a TI-84, if I were to say, raise your hand if you have a TI-84 calculator, they will raise their hand. Even though they also have a tablet, they still have a TI-84. So if there are 16 people with a TI-84 total, then that means that the 13 people would count, and then I would need an additional 3 people who only had TI-84s to make my 16. Then the next one we have is that 21 of them have a tablet. So 13 of them already have a tablet and a TI-84, so 21 minus 13 is equal to 8. So we have 8 people that have a tablet only. So then if I take 8 plus 13 plus 3, that gives me 24 people. And it says here that I have a total of 29 members, which means that I have 5 people in the math club that do not have a tablet or a TI-84 calculator. So part B, it says, find the number of members with a tablet or a TI-84. So I have 8 people with a tablet only, 13 people with both a tablet and a TI-84, and 3 people with a TI-84 calculator only. It says they have to have either a tablet or a TI-84, so that is the union of the two, which means that I would notate it as the number of people with a tablet or union a TI-84 would be equal to 24 people. Because I don't care which one you have, as long as you have either or. Part 2, it says a TI-84 but not a tablet. So if I have a TI-84 but not a tablet, that means I'm only looking at these 3 people because they're in the TI circle, but they cannot be in the intersection of the two. All right, so those number of people would be 3. Number 2, it says there are 40 students at an IB school who are studying either chemistry, biology, or both. 25 students are studying chemistry, 19 students are studying biology. How many students are studying both sciences? So here, if we draw a Venn diagram, there are 2 circles. We have chemistry and we have biology. We don't know how many people are studying both, so when it says how many people are studying both sciences, we are going to label that within X in the middle. Okay, so now it says, if we work backwards, 19 students are studying biology. So that means the number of people who are studying biology only is going to be the 19 people minus the people who study both chemistry and biology. And then it says that we have 25 students studying chemistry, which means that the number of students studying chemistry by itself is going to be 25 minus the intersection of people that are going to be in the middle studying both. because you don't want to count people twice. The people who are in the intersection count for both chemistry and biology, so you have to subtract them from the total so that they are not counted more than once. All right, and then they say that there are 40 students in an IB school who are studying, okay, total. So that means that I can create my equation. I could say 25 minus x plus 19 minus x should be equal to 40. When I do that, I can simplify by combining like terms. And when I combine like terms, I get 25 plus 19. That equals 44. And then I know that a negative x and a positive x will cancel each other out, which will just leave me with a negative x. So I will end up having negative x plus 44 is equal to 40. Or if you wanted to, you could write it as 44 minus x, same thing. And then I will end up subtracting 44 on both sides. So I will get negative x is equal to a negative 4, which means that positive x is equal to a positive 4. So it says how many students are studying both sciences. The answer is going to be 4 students are studying both. That is what x is. All right. So that is the answer to number 2. Number 3, it says a city has 3 basketball teams in the National League. In the last season, 21% of the city's population saw Team A play, 25% saw Team B, 29% saw Team C. Of these, 5% saw both A and B, 7% saw both A and C, and 6% saw both B and C. 3% saw all 3 teams play. Using a Venn diagram, find the percentage of the city's population, and then we can solve those problems at the bottom. So if we draw a Venn diagram, we have 3 teams. Team A, B, and C. So I'm going to have 3 circles. All right, so I'm going to label it A, B, and C here. Remember, you always want to work from the inside out. So it says 3% saw all teams play. So 3% goes in the middle, so 3 goes here. It says 6% saw both B and C. So if we look at the intersection of B and C cross in this area here. So I already have 3 people in that area. So I know that 6 minus 3 means I have to have 3 people who saw B and C only, who did not see Team A. The next part, it says 7% saw both A and C. So A and C cross here. And 7% saw both A and C, and I already have 3, so that means I need 4% who saw A and C only. Then it says that we have 5% that saw both A and B. A and B cross here, and I already have 3, so 5 minus 3 is 2, so there were 2% who saw teams A and B only. And then now we can go back to where it says that we have our totals. So for our totals here, it says that 29% saw Team C. So if I know that 29% saw Team C and all, I can take 29 and I can subtract 3, 3, and 4. So I'm subtracting 10. And 29 minus 10 is 19. So there were 19% who only saw Team C play. Okay. Then it says 25% saw Team B. So if we do 25% and we subtract the percent who saw Team B, which is 3, 3, and 2, so that's subtracting 8. That means 17% saw Team B only. And then it says 21% of the city's population saw Team A. So if I say 21% and I subtract all of the numbers that are in A, which is 9, that's going to give me 12% that saw team A only. So what I want to do is, because we're talking about percentages, I already know we can go only up to 100%. So if I take and I add 12 plus 2 plus 17 plus 4 plus 3 plus 3 plus 19, that gives me 60%, which tells me that 40% of the population has not seen any of the team play. So now we should be able to answer our questions. What percent only saw team C play? That is going to be 19. Part B says we want to find the population that saw team A or team C play, but not team B. So they could either see A or C, but they can't see B. So they could see 12%, 4%, and then 19%. When we add those, 12 plus 4 plus 19 equals 35. So that's 35%. And then part C, it says did not see any of the teams play. So that is easy. That's on the outside of the circles, which is 40%. All right. So last but not least, number 4, it says there are 50 people in the band. The director wants to know who can play the saxophone, who can play the trumpet, and who can play the drums. He discovers that 22 people can play the trumpet, 15 people can play the drums, 18 people can play the saxophone. 7 people can play the saxophone and the trumpet, 5 people can play the trumpet and the drums, 3 people can play the saxophone and the drums, 8 people, do not play any of these instruments, and they want us to find the percentage of students who played all 3 instruments. So the first thing that I need to do is, when I make this Venn diagram, I need to have 3 circles, of course. So we have saxophone, trumpet, and drums. So remember, you always want to start from the inside out. Well, the question is asking, what is the percentage of people who play all 3 instruments? I don't even know how many people play all 3, so I'm going to put an X in the middle. Okay? Then from there, we work backwards. It says 8 people do not play any of these instruments. So that means that I have 8 on the outside. It says that you have 3 people who can play the saxophone and the drums. So the saxophone and the drums, they cross here. So I know that there are 3 people in this area. So I'm going to say that the people who play saxophone and drums only will be 3 minus X here. The next part, it says that 5 people can play the trumpet and the drums. So the trumpet and the drums cross here, which means that I'm going to have 5 subtract the number of people that are in the middle. Then it says that there are 7 people who can play the saxophone and the trumpet. The saxophone and the trumpet are in these 2 sections. So I'm going to have 7 minus X here. And then we can go to where we have the entire sections here, or the entire amounts. And I'm going to use, let's see, a different color. I'm going to use that blue here. Okay, so it says 18 people can play the saxophone. So the number of people that play the saxophone only would be equal to is going to be equal to 18 subtract the number of people in those other sections, which is going to be, I need to subtract 7 minus x. I need to subtract x, and I need to subtract 3 minus x. And when I say subtract 7 minus x and 3 minus x, we're subtracting everything. So that means I have to put it in parentheses. So here I can say that this is going to be 18 subtract 7 plus x minus 3 plus x. And I already know that a positive x and a negative x will cancel each other out. And this will leave me with 18 minus 7 minus 3. That's 18 minus 10. And 18 minus 10 is 8. And we will bring down the plus x. So this is going to be 8 plus x here. Now, if we start talking about trumpet only, same concept. It says that 22 people play the trumpet. So that means I have 22, and I'm going to subtract everything in the trumpet section. So I'm going to subtract the 7. So 22 minus 7. I'm going to subtract the negative x. So I'm basically distributing in the same step. Subtracting a negative x is adding an x. Subtracting the x in the middle. Subtracting the 5. And then subtracting a negative x means adding an x as well. All right. So with that, I just, once again, combine like terms. So 22 minus 7 minus 5 is equal to 10. And we already know that a positive x and a negative x is going to cancel. And that's going to leave me with plus x. So 10 plus x for trumpet only. Then we're going to have drums only. If we have drums only, that means it says we have 15 people can play the drums in total. So if 15 people can play the drums in total, I would have to subtract everything else that's in the drum. So I'm going to subtract the 3, which is minus 3. I'm going to subtract the negative x, which is adding x. Subtract the x in the middle, which is minus x. Subtract the 5 and subtract the negative x, which is plus x. So combine like terms. 15 minus 3 minus 5 is basically 15 minus 8, and that is 7. And then we already know that the positive x and the negative x cancel out, which is going to leave us with a plus x. So we end up having 7 plus x in the drums only section. So now to figure out how many students play all three, then we can just have the equation. And we can say that our equation is adding up everything in the Venn diagram. So I'm adding 8 plus x plus 7 minus x plus 10 plus x plus 3 minus x plus 5 minus x plus 7 plus x. I'm adding up all of those pieces, and I'm going to set them equal to 50 because there are 50 people in the band. So when I combine like terms of everything in the Venn diagram, I already know that every positive x and every negative x is going to cancel. So I have a negative x and a positive x here. They're going to cancel. A negative and a positive that's going to cancel there. So I only have one x that I end up being with, and I end up having 8 plus 8 plus 7 plus 10 plus 3 plus 5 plus 7. So that ends up being 48 plus x, or x plus 48. And that is supposed to be equal to 50. And I already know that this equation means that x is going to be equal to 2. So when it says find the percentage of students who play all three instruments, there were 2 students who played all 3. Let me make sure I color code that and put that in purple. So because there were 2 students who played all 3, we can easily say that our answer is 2 out of 50. And we know that 2 divided by 50, and then we have to times it by 100. That is equal to 4%. 4% of the people play all 3. That is our answer. All right, if you have any questions, please let me know, and you have a great day.